Students, in this video we are going to solve problems related to functions. I read the question now. Let A is a set which contains the elements 1, 2, 3, 4 and B is another set which contains the elements 1, 4, 9, 16, 25 and let F is a set which contains the elements set of ordered pairs where the first element, that is first coordinate, comes from set A and second element y belongs to set B and y is equal to x square. Show that f is a function and from A to B find its f of x. Find its domain and range. Show that f is a function from A to B. Here f is defined as a set only. It is not here proved as function. We need to prove that this set is a function. That is, this relation is set of ordered pairs are there. Hence, this set is a function. We need to prove it and we need to find its domain and range. So first what we need to do is we need to write set of all inputs. Inputs here, if you observe it, all the first coordinate elements comes from set A. We know that x is set of all inputs. All the set of those inputs comes from set A. Hence, this set is called as domain because domain is set of all inputs and range is set of all outputs. We know that output is denoted as y. It comes from the set B. But B can also be domain because codomain. B can be codomain. Codomain means it contains set of all outputs and some extra elements, but we are sure with domain, but we need to calculate range. First we will prove that it is a function and then we will calculate what is range. If you observe this, the first input we are giving to this function, if you observe this, y is equal to x square means output is equal to x square. That means y can also be written as f of x. Hence here the function is f of x is equal to x square and we are giving the first input here because x belongs to set A. We are giving the first input. The first input is denoted as x1. We are giving 1 and it goes as an input here and it gets squared here. So 1 square is 1. The output 1 has come. And then we are giving second input, that is 2. It goes inside the function. It is gets squared. So 4. Similarly, next input 3, 9, x power 4, x4, that is input 4 is equal to 4, the corresponding output is 16. If you observe this, all these inputs are given to all these valid inputs are given to the function. All these inputs have produced unique output. It means that the input 1 produced only one output. It does not produce two different outputs. Input 2 produced only one output, input 3 produced only one output, input 4 produced only one output. They didn't produce two different outputs. Hence, this relation can be called as a function. Now we already found out what is domain. Now we need to find out what is the range. If you see the definition of range, it says that range is set of all outputs. Here the outputs are 1, 4, 9, 16. Hence the range is a set which contains the elements 1, 4, 9, 16. Now we will see this, and there is one more element 25 which is not the output of any of these inputs. Hence set B can be called as codomain. Codomain means it contains set of all outputs and some extra elements are there in it. Hence set B can be called as codomain, but range of this function f of x is 1, 4, 9, 16 only. Now we will see the mathematical definition here. The function f produces this 1 produces output as 1, 2 produced output 4 here, and 3, the input 3 produced 9, and when we give 4 as an 4 as an output, 4 as an input, it produces the output 16. Hence domain of this function is set of all inputs, that is 1, 2, 3, 4, that is set A, and range means range of this function f means set of all outputs. Here outputs are 1, 4, 9, 16, right? And then codomain is codomain is set B. It means it contains set of all output and some extra elements. Sometimes codomain can also be equal to range, but in this problem, codomain is different, range is different, because range contains only 4 elements, codomain contains 5 different elements. Hence here range is the subset of codomain. Since every input produces only one output, that is unique image, f is a function from A to B. We proved it. Now we move on to next question. Let f is a set which contains set of all ordered pairs x comma y such that x comma y belongs to natural number, that is the x belongs to set of all natural numbers, y also belongs to set of all natural numbers, and y is equal to 2x. It means f of x. We know that y is an output. It can also be written as f of x. F of x is equal to 2x. Be a relation on natural number n. It is a binary relation, n cross n. When we have n cross n, the first set becomes the second set, means it is binary relation. Here relation on n cross n. Normally we denote it as n only. It means that domain is also n, codomain is also n. Here domain is set of all natural numbers, codomain also is set of all natural number. Find its domain and codomain and range. Is this a relation, a function? Now we need to check whether this relation is a function or not. In order to qualify a relation as a function, it has to satisfy two conditions. You know that all the valid input should produce an output, and all the valid input, every valid input must produce only one output. These two conditions must be satisfied by the relation to qualify it as a function. Now we will check it. Now if you observe it, domain of this function is the set f is n. Still now we didn't prove that it is a function, so it should be here mentioned as set only. Domain of set f is n, codomain of set f is natural number because it is n cross n, and range of f. Now we need to check the range of f. It means that function here, if you observe it, y is equal to f for 2 times of x. That means that whenever we give input, the mathematical function, what it does is it will multiply the given input by 2 and it will produce the output as y, that is f of x. Hence here set of all natural numbers is given as an input. Hence every natural number has unique double the number. Hence unique double. Every natural number has a unique double. Hence this is that is set of all even natural number. Hence this relation can be considered as the function. Based on that we can say that domain of f is natural set of all natural number, codomain is set of all natural number, range is the set of all outputs. Here it is even number. Set of all natural numbers are our range. If you observe the difference between codomain and ranges, codomain contains all set of all even numbers as well as odd numbers, but range of this function f contains only set of all even natural numbers. Here range is the subset of codomain. Hence we can call this as a function from n to n. Every element in n, set of all natural numbers has a unique image in n under this function f. Hence f is a function from n to n. I hope you understand this question. Now we move on to next question. Which of the following relations are functions? Give reason. In case it is a function, means we need to find out its domain and range. And we will look at the first set. F is a set which contains set of all ordered pairs 1, 3, 1, 5, 2, 3, 2, 5. We know that the first coordinate is input, second coordinate is output. Here when 1 is given as an input for this function f of x, it produces the output 3. And then again when we give 1 as an input and it produces the output 5. It deviates from the function concept because the one valid input must produce only one output. It should not produce two different outputs. But if you observe this, when 1 is given as an input for this function, it produces two different outputs. They are 3, 5. Hence it is not a function. Even if you observe here, when 2 is given as an input, it produces two different outputs, 3, 5. Hence this set, this relation is not a function. You just observe is one element, namely 1 has two images. Images means output. Then 1 produces two different outputs. They are 3, 5. Hence f is not a function. Now we observe, we will go to the next question. G is a set, otherwise a relation which contains the set of all ordered numbers. Now we will observe it. Now we will check whether it is a function or not. When we give 2 as an input, it produces output 1. 5 as an input means again it produces 1. See, 8 as an input means it produces 1. 11 is an input means it produces 1. Hence it is a function, because when 2 is given means it produces 1 as an output. When we give 2 as a function in different times, it does not produce any other output. 2 produces only one input. It does not produce two different outputs. Here if you observe it, when 5 is given as an input for this relation G, it produces only one output, that is 1. It does not produce two different outputs. 8 also produces only one output. 8 does not produce two different outputs. Similarly, 11 produces only one output. It does not produce two different outputs. Hence it can be called as a function. But some of you may have a doubt that they all have same output. Is it correct or not? That is what you will say. As per the definition, one valid input must produce only one output. It should not produce two different outputs. That is the main characteristics of the function. And one more thing is, it should all the valid input must produce output. Here 2 is given as an input, it produces only one output. 5 is given as an input, it produces only one output. 8 is given as an input means it produces only one output. It does not produce two. Similarly, 11, it produces only one output. All the valid inputs produces output, and the input produces only one output. It does not produce two different outputs. As per those two conditions, we can say that this relation is a function. Again, I hope you understand this. This is a function. Since it is G is a function, we have to define what is their domain and range. As you know, domain is set of all real numbers, set of all inputs. So 2, 5, 8, 11 are their elements of domain, and range is 1 only, because 1 is not repetition of elements is not allowed inside a set. Hence range of this function G, actually here I need to write this as G. Range of function G is 1. I hope you understand this. Now we move on to third one. Here H is a relation which contains set of all this ordered pairs. 2 is given as an input, it produces 1 as an output. 4 is an input. 2, if you observe this, all the different outputs produces unique image. That means they are producing only one output. They are not producing two different outputs. And all the inputs 2, 4, 6, 8, 10, 12 have outputs. It means that they are the valid inputs are producing output. No input is not produced. No input is producing no output. Hence it is a function. So H is also a function. Domain of H means, as you know very well, it is all set of all inputs, that the first coordinate, and the range means set of all second elements. Hence these are the domain and range of this function. Now the next question is, function f is defined by f of x is equal to 2x minus 3. Find f0, f5, f of minus 2. It means that here in the first question, 0 is given as an input for this function. Here x value is equal to 0. X is equal to 0 means input is 0. 0 is given as an input means in this place of x, that is input place, we should substitute 0. So 2 into 0, 0, 0 minus 3 is minus 3. Here where they ask what is the output produced by the input x under this function. So when we substitute 5 in place of x, we are getting 7. Hence f of 5 is equal to 7. And then when we give minus 2 as an input for this function, what is the output? That is what they ask here. So we get the answer as minus 5, minus 7. I hope you understand all these concepts clearly. I again and again tell you that this concept is very important for 11th and 12th standard mathematics. I hope you understand all these concepts. Thank you students. Thanks for your cooperation.